In this video, we're going to go through and actually set up the animation instance. So currently, again, we have everything set up, however it's written in Blueprint. We want to move the event graph code over into C++ for obviously efficiency reasons, as well as I find it a little bit easier to work in this case. So triggering off pretty much whatever we need to do, such as interpolation, doing that inside of the update tick for the animation is a little bit just kind of easier in my opinion to do in C++, because you don't have this giant node mess that you end up getting in Blueprint. So to begin, I'm going to go through and create a new C++ class. Go all and search for anim instance. Select that, public, and let's give it a name of, let's see, IK anim instance. I don't know really any other name. And I'm going to put it in, actually, we don't need to know a separate folder because we're probably only going to have one or two classes. So go ahead and hit create project or create class. And here we have it. That is our character. Let's move that over. And here we have our animation instance. And this is what we're going to use to actually drive our animation blueprint. So I cannot think of any variables we might need. Let's go ahead and create a constructor anyways. So make a public section. Go through, generate the implementation. And we want to have the event, so the event blueprint update animation. Can't remember exactly what it's called. It's like native, is it native update animation, and takes in delta seconds. So we're going to go ahead and add that, as well as we want the function for the begin play. So native begin play. Create the implementations for both. Make sure to call super. I don't know if it really matters in this case, but just to be safe, because with half the time it breaks everything else. So super, native begin play, and native update animation. So once we have that, we want to actually start converting things over. So for example, in begin play, we're just going to get this basic setup. So we want to store a couple things, like obviously we want to store our character as a variable. So we're going to have a pointer to our character in our animation instance. We want to have our sight transform and the hand transform. So let's go ahead and move that on over. And honestly, I'd probably just leave these as blueprint accessible, so you're not having a bunch of getter functions. So I'm going to do u property, and we're going to do blueprint read only. And I'm just going to set the category to tutorial. Okay, so the first one's going to be our character. So we want a ADS tutorial character as a pointer. And obviously it included it automatically, which is something I do not like. So we want to forward declare that. And we want to go ahead and set this. So I'm just going to call it character. Okay. Once we have that, we also want to have our sight transform and our relative hand transform. So this can be F transform, relative hand transform, and our sight transform. Okay. Once we have those, we can start modifying that inside of native begin play. So we're going to go ahead and set our character, and that's going to be the owner of this blueprint or animation instance. So if we do get owner, we can see try get pawn owner. We can do that. We can go ahead and cast it out. So character equals cast. Actually, is it a template? No, it is not. So we're going to go ahead and cast it to a ADS tutorial character from try get pawn owner. And we have to include our character. So we're going to go ahead and include ADS tutorial or tutorial character.h. So hopefully this will set it. So just in case I want to do a check. So if character, we're down to log, because I'm too lazy to use the debugger. Valid character. Okay. And I want to do it else. Okay. Once we have that, we're going to go ahead and give it a try. So again, we made some changes. We're going to go ahead and restart the editor and launch it up. Okay, once that is done, I don't see a reason to relaunch those. Let's go ahead and create a, well, we don't have to create a blueprint version, but what we can do, I want to place most of my stuff inside of content. So I want to create a new animation blueprint. As you can see up here for the parent class, we have the option to select our animation instance that we just made. So I'm going to select that, and the skeleton is going to be for the mannequin arms. So it's going to be AnimBP C++. Open that up and go to our first person blueprint. Let's go ahead and set it to use it. So AnimBP C++ and check the log. So, valid character. So we're good to go. So we are actually getting our character and everything set up just to make, I just wanted to make sure it worked. Now we can move on to some more, I guess, interesting things of continuing on the setup. Let's find that original animation blueprint right here. We're going to go ahead and create some functions just like before, where we set site transform and set our relative hand transform. So we can actually, might as well make these protected since, yeah, I can't see any reason to actually call them. That's going to be void set site transform and void set relative hand transform. Create the implementations. And we want to trigger these in the same fashion. So if we look at the event graph, when we have our begin play, we set our character, then we added a delay. And we use that delay before we call these two functions. Now that's due to as a kind of a precaution. So in my other project, what would happen is whenever, for example, this would try to run, we would have some issues because we would have null pointers. So the reason for that, well, better yet, this will be a better example because we're getting the optic. So I would have a separate firearm class, then a separate optic class. So you would spawn the firearm, then the firearm would then spawn the, correct attachments such as the optics, for example. And when that would happen, that would be kind of too late. It's like, so it would spawn it too late before these were called. So we would have a null pointer on the optic and or the firearm as well. So that's why we're adding the delay. So we want to trigger these using just a simple timer. So native begin play, we can do get world timer, and what is it? World get timer manager dot set timer. And we're just going to have some temporary timer handles. So F timer handle, T, let's do, what's it called? Set site transform. As well as T set relative hand transform. So we're going to have two timers running off of these handles. So we set the handle. Then we want to go through and do the reference to the class, which is this. Then we want to have the actual function. So in our case, it's going to be UIK anim instance, set site transform. And then we want to have that kind of delay. So I'm going to do 0.3 seconds and false because we do not want it to loop. Let's create the second one. And it's going to be for our relative hand transform. Again, we go through and we change the function name that it calls, like so, and we are good to go. So that should trigger these two and then destroy itself. Once we have that, we need to set up the logic inside of it. So for set site transform, that should be our camera. So we get our character, we get our camera, and we make our camera's location relative to our first person mesh's location. So if they were doing this for third person as well, we would have a separate one of these, and that would be for the third person mesh. So that kind of allows you to get a rough position. Then we want to go ahead and make them relative. We find a spot in front of the camera where we set the location. So in our case, if you recall, and of course it's not going to play because I have the animation set up to a different one. Let me show you a quick example. That'll be the original first person mesh, or first person AnimBP. Yep. So it aims, and the optic is roughly that far away, so we can see it from the side view, where it is. We increase this up to like 65. You can see it pushes it a good bit farther away. So that's kind of the premise of where we're going to be working with. So let's go ahead. We are calling these, so we want to set the site transform first. So we go through, we get our camera's location, the world transform with both the camera and the mesh that we are working with. We make it relative, so that'll be in the Kismet math library. We find a position out in front, and we set our site transform. So we want to go ahead and get our character, and I'm going to do a check here. So if, actually this will only run if the character is valid. Let's set it that way. So if character, so for whatever reason, character is invalid, we're just not even going to fire it off. So character, get first person camera component, get component transform. Now that went through and included the camera component automatically. So if you're on Visual Studio, go ahead and include that like so. And let's save it. So F transform, cam transform, and assign it. Okay, now we want to do the same thing, but for the first person mesh. So we're going to do character again. So let's create another transform. Mesh transform equals character. Mesh, get mesh 1p. Get component transform again. Now using the Kismet math library, we want to include that. We're going to include Kismet math library.h. And we're going to do F transform relative equals U Kismet math library. Make relative transform. We're going to go from the cam transform as the source, and then the one we want to make it relative to is our arm, so our mesh transform. And I don't remember if there's any other parameters. I don't think so. Nope. So we now have our relative transform, which would be this output right here. So we want to store the rotator. Actually, no, we're going to add vectors, so we want to do F vector, new site vector, and we want to set that equal to relative dot get location. So this is where we're going to go through and do the little multiplication to kind of get that position out in front of our camera that we want to set it. So we're going to go ahead and make our relative transform, which we did. We want to take the rotation of that transform, get the forward vector of it, multiply it by a value of whatever we want. In our case, we're just going to do 30 for the time being, in which case we add it, that new vector position, to the original location. So we're adding it essentially to the new site vector. So we want to do F vector. Let's do forward vec equals relative dot get rotation dot get forward vector. So that'll give us this node right here. So we want to take forward vec, we want to multiply it by 30, and in which case we take this value and we add it to the return value of relative. So I'm breaking this up into a bunch of different vectors. We can combine these so we don't have to have so many, but for the time being, I think this is this will work. Oh, in my head anyways. So we're going to go ahead and we take that forward vector. So we want to do new site vector, and we want to add forward vec to it. So that should give us that position in space in front. So pretty much our camera, let's assume it's right here. It'll give us a position about 30 centimeters in front of it. And then once we have all that information that we really need, we can assign it to our site transform. So site transform dot set location, that's going to be the new site vector. Then the site transform dot set rotation, that's going to be our relative dot rotator. And as you can see, it's giving us an error because this wants it to take in a F quaternion. So we just do dot quaternion, and that'll convert it for us. So we have our transform, which contains our location, the rotation, and the scale, which we are just flat out not going to use. Okay, so I'm going to leave this as is for now because I mostly want to get this testing and working, and then we can come through later and clean this up. So now let's move on to set relative hand transform, which is a little bit simpler. So all that is we want to get the current optic that we have. We want to get the socket for it. We make that relative to the right hand socket as shown here, and we assign it. That's it. So again, we do F transform. Let's do mesh transform, and we go ahead and set that up to be the exact same. And then we can do the same thing again. So F transform. Let's do optic socket transform. And we can assign that to be character, get current. Let's see. We do not have a get current optic. We do, but it's protected. So what we can do is create a simple, let's create a getter function for this. So in our character at the end, we're going to do, it's going to be, yeah, it's a static mesh. So use static mesh component. It's a pointer. Get current optic. And we're going to return our current optic. We now call get current optic. And from there, we want to get socket transform. So the type F name, and the socket we want to get is s_aim. So that's going to be the socket that we positioned right here in front of the dot. So s_aim. Okay. Let me think. That should be pretty much it. We just make it relative. So we can do, what was it? Relative hand transform equals Kismet math library. Make relative transform. We're going to do the optic socket transform to the mesh transform. So we're making our optic socket relative to the mesh transform. So to make sense with ordering, let's reverse these. And to prevent a crash, we are going to do a null pointer check. So if character get current optic is valid, then we will run everything. Otherwise, I want to go ahead and print out a log stating that it failed. So uv log temp, warning, text, failed to get current optic. Let's add actually one more of these just to make sure. Failed to get character, just so we can debug this down a little bit easier. And I think we are pretty much good to go. So let's go ahead and close down the engine, save everything, and recompile and relaunch. Okay, once that's done, let's see what all we need to open. We shouldn't need our character, but let's open up our animation blueprint that we just made based off of our animation instance. Let's go to the anim graph. Let's go to our animation graph and copy everything inside of it from the blueprint version. Okay, and link it up. and compile, save. So because we named the transforms the same, everything pretty much carried over. So now let's go back to our first person character, set it to be our new C++ animation blueprint, and hit play. Okay, so we are having an issue here. Let's see. And that is still getting set. However, it is not being set to the correct position. And I didn't see any errors getting printed out. So let's go ahead and double check. Or better yet, let's actually increase so we can visually see what's going on. The delay here, so let's do 2 seconds. On live coding. Okay, so it is setting the rotation everything correctly. However, it seems like it is the location itself that is off. So what we can do is let's go ahead and make sure this is all still looking correct, which it is. Let's look back and see what might be the cause of this. So my assumption off the bat is going to actually be the site transform, but let's work our way back. So we have our set relative to hand. So we get the current optic, which is this line right here, as well as the first person mesh, which is that transform right there. And I found the issue. So we're going off of the socket transform, and I did the mesh itself, so the component transform. So what I'm going to do is get the mesh 1p, get socket transform, and that's going to be fname and underscore r with a lowercase h. So run hot reload again. And did that say it was successful? Yes, it did. Okay, run that again, and are we still having the same issue? Oh, nope, I forgot we had a bigger delay. Let me actually revert that delay back to, what was it, 0.3? Okay, and there we go. So we now have our C++ version of it back up and running. So we now no longer need our animation blueprint for the blueprint version. We can instead build everything off of our C++ version and add some interpolation, as well as the ability to switch between all of these optics. So that's what we're going to begin working on in the next video. So we're going to stop this here. We can close out of U, and let's see. Trying to think if there's anything else that I want to do real quick, and I can't think of anything off the top of my head. So that's going to be all for this video. If you like what I'm doing and you want to help support me, you can find a link to my Patreon down in the description below, where I have a Team Deathmatch series just for Patrons, as well as you'll get early access to these videos, such as this one. If you have any questions or anything like that, feel free to join my Discord that's linked down below, and I'll try to help you out. So I'll see you in the next video.